Alright, so now let's solve this SQL problem called exchange seats. So over here we are given a table called seat which contains two columns, the ID which represents the seat number and the student name, right? Now our task is to swap every pair of adjacent students, right? So the student sitting in seat 1 should move to seat 2 and the student sitting in seat 2 should move to seat 1. Similarly, the student in seat 3 swaps with seat 4 and seat 4 swaps with seat 3. However, there is one important edge case. If the number of rows is odd, the last student should remain in the same seat because there is no adjacent student available to swap with, right? So let's understand this with the help of an example. So over here we have 5 students. Seat 1 contains Abbott, seat 2 contains Doris, seat 3 contains Emerson, seat 4 contains Green, and seat 5 contains James. Now after performing the seat exchange, Abbott and Doris swap these seats, right? So Doris moves to seat 1 and Abbott moves to seat 2. Next, Emerson and Green swap seats. So Green moves to seat 3 and Emerson moves to seat 4. Finally, we reach seat 5, which contains James. Since there is no seat 6, this student cannot be swapped with anyone. So he stays over there in seat 5. Now this produces our final output table, right? Which is this. Now maybe let's understand the logic needed to implement this in SQL. So now instead of physically swapping rows in the table, we will take a smarter approach over here, right? We will compute the new seat ID for each of the row. So let's just go step by step. First we check whether the seat ID is odd, right? If the seat ID is odd, it normally means this seat should be swapped with the next seat. For example, seat 1 swaps with 2, seat 3 swaps with 4. So when the seat ID is odd, we simply move the student to ID plus 1. But we must be careful with one edge case. If the odd seat happens to be the last seat in the table, then there is no next seat available, right? So in that situation, we leave the ID unchanged. Next, we handle the even seat IDs. So even seats represent the second seat in each pair. For example, seat 2 swaps with 1, seat 4 swaps with 3. So when the seat ID is even, we simply move the student to ID minus 1, right? So let's quickly summarize the logic. If the seat ID is odd and it is not the last row, we move it to ID plus 1. And if the ID is even, we move it to ID minus 1. And if the seat ID is odd and also it is the last row, we keep the ID unchanged. And once we compute these new IDs, we simply sort the result by ID to produce the final seating arrangement, right? Now maybe let's translate this logic into SQL. So we start with the select statement. Now inside the select clause, we compute the new seat ID using a case expression, right? So the case statement allows us to apply different rules based on conditions, right? We already know that. Now our first condition checks whether the ID is odd. And we do this using the modulo operator. So when we compute ID modulo 2, an odd number produces a remainder of 1. So this condition identifies odd seat numbers, right? But we also need to make sure that this is not the last row, right? So to detect the last seat, we run a subquery that finds the maximum ID in the table. And if the ID is odd and not equal to the maximum ID, we then apply the swap rule. In this case, we return ID plus 1, meaning the student moves to the next seat. Next, we handle the case where the seat ID is even. Now, if the ID modulo 2 equals 0, we know it is an even seat. So for these rows, we simply return ID minus 1, which swaps the student with the previous seat, right? Finally, we handle the remaining scenario using the else clause. This occurs when the seat ID is odd and also the last row in the table. And since there is no adjacent seat available, we return the same ID without modifying it, right? And we also select the student name, right? And we select all of this from the seat table. And finally, we apply the order by clause on the ID. And this ensures that after swapping, the rows appear in the correct seat order, right? So once we run this query, we get the final output, which looks like this. And this is the same output that we saw in the problem statement slide. So this successfully completes the seat exchange, right? So that's it for this particular problem. I hope you understood the approach and the solution well. And now I will see you in the next one.